You can start the session, sir.
Good morning, everyone. So, in the last class, we were discussing about the qualitative and quantitative analysis. So, we'll continue with it. And we have done the formation of Lezange's extract. So, let me revise just first what you have to do. Freshly cut sodium, just a small pea size. Heat it in the fusion tube till it forms a shining globule. Then remove up the flame. Okay. Then add organic compound. Heat it at least 2 to 3 minutes till it become red hot. Then plunk that tube into the china dish, which contained 10 to 15 ml of distilled water. Then boil it, cool it, filter it. Then you'll get the sodium fusion extract. Okay, so we have to use this extract. So what exactly happening? Let's discuss about the chemistry behind it. Okay, so what exactly happened? Sodium react with the carbon and nitrogen content. Okay, this carbon and nitrogen from the organic compound, and the sodium, when we heat it, they form a compound that is NaCN, inorganic compound. Okay, that is NaCN. Now, what you will do? You'll heat the filtrate. This NaCN is the filtrate with the ferrous sulfate. So NaCN, when react with FeSO4, it will form Na2SO4 plus FeCN whole twice. Okay, so when you start heating this ferrous sulfate with the filtrate heating, so they form sodium sulfate and ferrocyanide. Okay, or you can say iron cyanide. Okay, so this FeCN2 again react with the 4 molecules of NaCN. It will form Na4 FeCN whole 6. This is a coordination compound. Name of this compound is sodium hexacyanoferrate. Second, ferrate. Second, double R. Sodium hexacyanoferrate. Second, and when this sodium hexacyanoferrate react with the excess Fe3 positive, or you can say FeCN. So 3 molecule of Na4 FeCN whole 6. Then they react with the excess Fe3 positive ion. It forms Fe4 FeCN whole 6 whole thrice plus 12 Na positive. And this particular compound is known as iron third hexacyanoferrate. Second, and it shows Persian blue color. So see, the extract is heated with the ferrous sulfate. It forms sodium hexacyanoferrate, which on reaction with the FeCN again forms Fe4 FeCN whole 6 whole thrice, that is iron third hexacyanoferrate second. This shows Persian blue color. Okay, so this is if in the solution Persian blue color is present, it means there is a presence of nitrogen in the compound, organic compound which you are taking. Okay, so this was the test for nitrogen. If nitrogen and sulfur both are present, condition is if nitrogen and sulfur both are present, and you need to check both in a single compound, then you'll make the same extract. Okay, it will form just because Na will react with the C plus N as well as also with the sulfur. So the compound on heating it will form NaSCN. That is called sodium thiocyanate. And this sodium thiocyanate when react with Fe3 positive ion, it will form FeSCN whole thrice plus 3Na positive. And this compound is known as ferric thiocyanate, and it shows blood red coloration. So a blood red color is shown in the compound, then it means there's a possibility of having nitrogen as well as sulfur in the compound. Okay, so this much is clear for the detection of nitrogen. The reaction you have to remember. Okay, see, for the detection of, we have done Lagrange's test. Second test for the detection of nitrogen is dry heating test. Dry heating test. So in dry heating test, what exactly happen? If condition is if organic compound is continuously heating, or you can say if organic compound contain nitrogen and we need to check it is heated strongly, just heat it. If it heated strongly, it gives smell of burning hair, or you can say feather. Just like a smell is there when you burn hair or feather, the same sort of smell will be there. But this test has a limitation. What is the limitation of this test? That it is not reliable since many compounds which do not have nitrogen, or you can say many compounds which have nitrogen but not give this test. So sometimes question can be asked like dry heating tests, why we are not using, just because some of the compound which contain the nitrogen but still they are not giving this particular test, so they're not giving that smell. That's why this particular test is not used. One more test for detection of nitrogen is soda lime test. We are detecting only, we are not right now calculating the percentage, we are just detecting. Okay, so just when we are detecting the compound, we are say it as qualitative analysis. When we will determine the amount, then it will known as quantitative analysis. Okay, so right now we are discussing about the qualitative analysis. So in the soda lime test, what you have to take a pinch of the organic compound, just a small pinch. Okay, pinch of the organic compound is heated directly. What you have to do, pinch of organic compound is heated, is directly heated in test tube. Condition is with NaOH and CaO. Can anyone tell me the mixture of NaOH and CaO is known as? NaOH and CaO mixture is known as soda lime. Okay, so organic compound is heated with the soda lime. Okay, if a smell of ammonia is there, the smell of ammonia, it means It indicates the presence of nitrogen. It means nitrogen is present. For example, the reaction what exactly happen is NH2C double bond ONH2. For example, I'm taking a compound that is urea. I'm taking a small pinch. It react with the 2NaOH in the presence of calcium oxide. So we are making a mixture of soda lime. It will form 2NH3 plus Na2CO3. So ammonia is there. But why I was not using this test? Limitation. What was the limitation of this test? Limitation is again some compound like nitro, you can say NO2, or you can say azo compounds and double bond N. This is azo group. See, these compound will not give this test. So when these type of compound which contain the nitrogen but still they are not giving this test, so it means this is not reliable for every organic compound which contain the nitrogen. Okay, so this is not reliable. Yes. Any doubt in this? Lagrange's test, dry heating test, and soda lime test for the detection of nitrogen. Any doubt? Yes or no?
No, sir.
Okay. Next one is detection of halogen. Okay. So for the detection of halogen, first test I'll use is Bilstein test. Bilstein test. See, in the Bilstein test, what you have to do, you have to it just generally, if I talk about this particular method, this is very simple method. Okay, so in this particular test, we used to see the color of the flame. So first you have to do, I'm making again flow chart for you. Okay, for this particular test, clean and stout copper wire. Clean and stout copper wire is used, which is heated. Okay, when it is heated, a non-luminous flame is present. Then what you will do, you will touch that particular the heated end of wire is touched with organic compound. It's touched with organic compound, then again heated on Bunsen burner. Okay, so when this particular thing will happen, then we'll again observe. So first you have to take a simple clean, not clean, it's clean. A clean and a stout copper wire, straight copper wire, which is just you can say uh, sort of this at the end it is turned so that it will sort of knot is there. You'll heat it, and when you'll heat it, there was a non-luminous flame. There was no change in the color, normal flame color. Then what you will do, you'll touch the heated end of that particular wire to the organic compound. Then again you'll go for the heating. Okay, so in the starting, you can see the green or bluish color was there when there was no organic compound was touched. When the heated end is touched with the organic compound, there is a change in the color. So if green or bluish color is observed, green or bluish flame is observed, it means halogen is present. It means halogen is present. So same. So, but if you see, we have chlorine, we have bromine, we have iodine. But Bilstein tests only tell about the Bilstein test only tell about the halogen is present. It is not telling which halogen is present. The first limitation is very simple. If I talk about the first limitation is very simple, that uh, not specific. It's not specific. It is only telling the halogen. Okay? Do not tell which halogen. Either it's chlorine, either it's bromine, either it's iodine. So we'll talk about only chlorine, bromine, iodine. Okay, we'll not talk about the fluorine. That is a very electronegative and shows the anomalous properties. Okay, so not this is not specific. Second thing, if I'll say about the limitation of this compound, certain organic compound like urea, thiourea, they do not contain any halogen, but still there was a change in color. So it means they were giving the test, gives this test, and we are checking for the halogen, and they do not contain any halogen, but still they are giving the test. It means this particular test is not good, okay, or not sufficient. So again we will use which test? Lassan's test. Okay, so in this particular test, again you will make the extract same way, same process for making the extract. What will happen? Now the sodium will react with the halogen which is present in organic compound. Same, see, you have to make the same way Lassange's extract was made earlier. Now you'll add the organic compound, you'll heat it, cool it, filter it, extract is formed. Now in the extract, what exactly happened? The Na will react with the X. On heating, it will form NaX. And here X can be chlorine, bromine, or iodine. Okay, so now let's see what you have to do when the extract is made. So if first, what do you have to do? First, the extract. First, the extract is boiled. Boiled with dilute HNO3, and then you'll cool it. Okay. First thing, what you have to do with the extract, you have to boil it with dilute HNO3 and then cool it. And some few second step, what you have to do, few drops of silver nitrate is added. Okay, so now you'll see what happened. First case A. If NaX X is Cl in the extract, NaCl is formed. It react with AgNO3. It will form AgCl plus NaNO3. AgCl, it means white PPT. If white PPT formed in the test tube, it means there is a presence of chlorine in the organic compound. Second, if NaBr, X was Br, it react with AgNO3, it will form AgBr plus NaNO3, and the color of AgBr is pale yellow. A PPT of pale yellow PPT formed, and here it is again the condition for bromine. Third condition, NaI when react with AgNO3, it means the X was I. You will see AgI plus NaNO3, and in AgI yellow PPT formed. Okay, so this is what you have to remember in this test. So is this clear? Is this clear?
Yes, sir. Yes, sir.
Okay. Let me check any other test is there. Okay, yeah, let's answer. See, we have certain tests. Carbon disulfide test is also there for the detection of halogen, but 2 tests is, I think, sufficient. Okay. So, why we are using the NO3 in this particular compound? HNO3. See what exactly happened. By the addition of this HNO3, the sodium cyanide which was forming, NaCN, will get destroyed, decomposed. Okay, so that's why we are using HNO3. Okay, let's discuss about the now detection of sulfur. Yeah, we'll go for the detection of sulfur now. Detection of sulfur in the organic compound. So for the detection of sulfur, we have 2 tests. First, we'll go for the Lagrange's, and then we will go for the what? Oxidation test. Okay. So first test we are using. Wait, give me one. Okay. First test is again Lagrange's test. So you will make the extract. You will make the extract, and in the extract, the sodium will will react with the sulfur, and on heating, it will form Na2S. Sodium sulfide. Okay, it will form sodium sulfide. Now, what we have to do with the sodium sulfide? We have 2 tests. First test we can do is sodium nitroprusside test. Sodium nitroprusside test. For the sodium nitroprusside test, what you'll do? You'll take a small portion of this filtrate. Okay, a small portion of filtrate. You'll take a small portion of filtrate. Then you will do acidification. Means you'll add a small amount of acid, or which acid? You'll add dilute acetic acid. Dilute acetic acid. What is the formula of acetic acid? What is the formula of acetic acid? Huh?
CH3COOH, sir.
CH3COH. Yes. Okay. Then you'll add few drops of sodium nitroprusside. Oh no, we are doing sodium nitroprusside. Okay. Yeah. So first what you will do? First you will. Okay. I think I start telling the. Wait. First, let's do lead acetate test. Lead acetate, yeah. A small portion of filtrate, acid, dilute acid, then few drops of lead acetate. Yeah, this is easy. First go for this one. Lead acetate. Okay. So when you'll add lead acetate in this particular compound, okay, you'll see a formation of black PPT. Black PPT formation takes place, and if black PPT formation takes place, it means sulfur is present. Okay, so the reaction what exactly happen is NaS formed will react with CH3CO called twice Pb, that is called lead acetate. It forms PbS plus 2 molecule of CH3COONa. This PbS is called lead sulfide and have a black color PPT. If black PPT formed, it means sulfur is present. Okay, so this was first for the lead acetate. Second, now we'll go for the lead sodium nitroprusside. Sodium nitroprusside test. See, it's sort of same. You have to take a small portion. Take the small portion. Then you'll again add some amount of few drops of sodium nitroprusside. Okay. If violet color appear, it means sulfur is present. Okay. For example, the reaction what occurs, that is Na2S. Okay. This Na2S will react with sodium nitroprusside, that is Na2 FeCN whole 5 NO. This is called sodium nitroprusside. So when it reacts with this sodium sulfide, it will form Na4 FeCN whole 5 NOS. So this shows violet color. Okay, so if violet color is present, it means sulfur was present. I think this much is clear. 2 test tube, the extract is added in the 2 test tube, different. In 1 test tube, we'll add lead acetate and acetic acid. So then black PPT formed, it means sulfur is present. In the second, what you'll use sodium nitroprusside. If violet color appears, it means there's a possibility of having sulfur in the compound. Okay, clear this test? Yes.
Yes, sir.
Okay, let's do for this second, that is oxidation test. If I'll go with the oxidation test for this sulfur, what I will do first, I will wait. First, what I'll do, the whatever the organic compound is given, okay, the compound is fused with potassium nitrate and sodium carbonate. Okay, if sulfur is present, then it will get oxidized. For example, KNO3. Okay, when it is heated, it will form KNO2 plus nascent oxygen. So if I'll heat potassium nitrate, that is KNO3, okay, the compound, for example, Na2CO3, sodium carbonate, it will react with the sulfur, will react with the 3 oxygen atom, that nascent oxygen. Okay, it will form Na2SO4 plus CO2. I made a gap between them. Wait, Na2, sodium sulfate. So potassium nitrate, sodium carbonate. But first, on heating the potassium nitrate, convert into potassium nitrate and oxygen, nascent oxygen. This nascent oxygen react with the sulfur along with the Na2CO3, that is sodium carbonate. It will form Na2SO4 plus the elimination of carbon dioxide is there. Now, what will do this Na2SO4? This Na2SO4 react with the BaCl2, barium chloride. Okay, barium chloride, you will see the formation of 2NaCl and BaSO4 is formed. And the color of this BaSO4 is white PPT. So this indicates the presence of sulfur. This indicates the presence of sulfur. So remember this. Clear? Yes. Okay.
Yes, sir.
So we have done the detection of nitrogen, we have done the detection of carbon and hydrogen, we have done the detection of sulfur, we have done the detection of halogen also. So let me check in your book which one is remaining, that is detection of phosphorus. Okay. See, for the detection of oxygen, we don't have any direct test. Okay. So I'll talk about it later. First, let's discuss the last one, that is called detection of phosphorus. So for the detection of phosphorus, what you have to do, you have to take the organic compound and fuse it with the oxidizing agent. organic compound is fused with oxidizing agent. An oxidizing agent, you can use sodium peroxide. Okay, so when the phosphorus present in the organic compound is oxidized, here it contains phosphorus. So the phosphorus present in the organic compound, when it oxidizes to sodium, it oxidizes to sodium phosphate. For example, you can see I'm taking an example Na2O2, sodium peroxide. When it is react with the phosphorus, that is phosphorus present in the organic compound, it will form, on heating, it will form Na3PO4 plus Na2O. That is sodium phosphate. Okay, now we'll take this sodium phosphate, and when this sodium phosphate react with the HNO3 and heated, so you can say that this fused mass of is separated with the help of water. Then this solution is heated with concentrated HNO3, and then what you will do? Then a compound formed is C, and the compound formed will be S3PO4 plus 3 molecule of NaNO3, sodium nitrate. Now this S3PO4, I will add small drops, or you can say small amount of ammonium molybdate. I will add small amount of ammonium molybdate, that is NH4 whole twice MoO4, that is called ammonium molybdate. I will add ammonium molybdate and heat it, and you'll see NH4 whole thrice PO4 plus dot 12 MoO3. This compound is known as ammonium phosphomolybdate. Along with this, 21 molecule of ammonium nitrate plus 12 molecule of H2O is formed. The color of this compound is yellow. So if yellow coloration or yellow PPT is found in the reaction when we add ammonium molybdate, it means the organic compound contain the phosphorus. So what you have to see again, organic compound which contain the phosphorus is heated with the oxidizing agent. Okay, it will form sodium phosphate. When this so the reaction is, I'm taking oxidizing agent as Na2O2, that is sodium peroxide. When it react with the organic compound containing phosphorus, form Na3PO4, sodium phosphate, and the along with this, it will form Na2O. Okay, this Na3PO4 is then acidified with a concentrated HNO3 and boiled it. We have to do the boiling here. You'll boil it, it will form S3PO4 plus 3 NaNO3. Now this S3PO4 will react with the ammonium molybdate, and when you heat it, it will form ammonium phosphomolybdate, which have a yellow color. And then 21 molecule of ammonium nitrate plus 12 H2O is formed in this reaction. So if yellow color is obtained, then it means there is a possibility of phosphorus in the organic compound. Okay, so clear?
Yes, sir.
Okay, so the qualitative analysis is finished. Now let's move with the important part of the chapter and the numerical base, that is quantitative analysis. Now here we have to calculate the quantity, the amount. Okay, when you have detect the various element present in the compound, what you have to do, you have to determine the percentage of each element present in the quantitative analysis. So let's discuss about the first type, that is called estimation of carbon and hydrogen. Estimation of carbon and hydrogen. So see, I'm making a diagram. In the next class, I'll bring some diagrams which are already drawn, so I'll not make them. Okay, this is a simple setup in which see, I'm writing what is from here. Pure dry oxygen will go. What is necessary condition? I'm writing what is necessary for this particular setup. I'll write only those things. Okay. So this first test tube, this U-shaped tube contain calcium chloride. So we say it as calcium chloride tube. Second one contain the potassium hydroxide. We consider it as potassium hydroxide tube. Okay. And this is a furnace. Okay. Inside which copper oxide, or you can say cupric oxide is present. And here we have one stand here. Okay, in which the organic compound is present. This is called platinum boat. Okay, then what this tube is known as, this is called combustion tube. Combustion tube. What else is, okay, here, from here excess oxygen will move out. So you'll see from the left to the right, I've mentioned everything, I think. Yeah. So I don't think that I need to mention the burner also, but this is burner. Okay, you guys know what is burner. Okay, and what is the work of furnace? This is furnace. For heating. Okay, so what will happen now? The organic compound, kept in the platinum boat, is heated with the CuO in the furnace. Okay, so the carbon from the organic compound react with the CuO, form CO2 plus 2Cu, while the hydrogen from the organic compound will react with the CuO, will form H2O plus Cu. Both the compound on heating will form CO2, but both the elements react with the CuO and form CO2 and H2. Now in this furnace, or you can say combustion tube, CuO was present, so it was reacting with carbon and hydrogen, and now CO2 and H2 is formed. Okay, so what you will do, you will weigh the weight, you will weigh the both U-shaped tube, calcium chloride tube and potassium hydroxide tube earlier, before this reaction occur. Okay, now what you will do, now you will take when this carbon dioxide and H2O will move forward, the H2O will get absorbed by the calcium chloride. The H2O, this H2O will get absorbed by the calcium chloride. See, if you remember the desiccator, if you know the desiccator we use calcium chloride just because it absorbs the water molecule. So this CaCl2 will absorb the water molecule while the carbon dioxide will move further into the second U-shaped tube. And in the second U-shaped tube, the potassium hydroxide, this will absorb the carbon dioxide, this will absorb the H2O. So this, when the carbon dioxide is absorbed in this particular tube, now the mass of this U-shaped tube will increase. Again, in the first case, the mass of CaCl2 test tube will increase. So what you will do, you will minus the mass of, you'll subtract the mass of earlier when the reaction was not proceeded. The mass you have taken before the reaction of U-shaped tube, you'll minus the mass and you will see there's an increase in mass in the both test tube, both U-shaped tube, sorry. And now you will calculate the percentage of them by this mass. So you will see the formula. I'm not telling the whole calculation, just directly the formula we have to remember, just because we have to do the numericals. So percentage of carbon will be mass of carbon divided by total mass of carbon dioxide, that is 44, into the mass of CO2 formed in the reaction, divided by mass of organic compound taken, mass of substance taken into 100. Then percentage of hydrogen is in water molecule, 2 hydrogen is present, so I'll write 2 above it. The mass of hydrogen is, water is 18 into again mass of H2O formed divided by mass of substance taken into 100. Okay, this much is clear. Okay, I'm writing one question here. One I will do, another one you will do. So the question is, on complete combustion, 0.246 gram of organic compound gave 0.198 gram of CO2 and 0.1014 gram of H2O. Determine the percentage of carbon and hydrogen in compound. So I need to calculate the percentage of carbon and hydrogen in the compound. So what I will do, first of all, whatever is given in the question, just write it. Total mass of substance taken. Mass of substance taken is equals to क्या हो जाएगा? That is 0.246 gram. Okay. Then mass of CO2 formed is 0.198 gram. Then you know our mass of H2O which is formed, that will be equal to 0.1014 gram. So let's start doing the calculation. So first I'll do the percentage of carbon. The formula is 12 upon 44. Okay, the mass of carbon dioxide formed is 0.198 divided by, what is the mass? 0.246 of substance into 100. Okay, and if I calculate the percentage of hydrogen, it will be 2 upon 18 into mass of water formed as 0.1014 divided by 0.246 into 100. If I'll calculate it, the percentage of carbon will be 21.95 and the percentage of hydrogen is 4.58. So I think this question is not that much tough. Got my point? Yes or no?
Yes, sir.
Okay, I'm giving you one question now. 0.6723 gram of an organic compound gave on combustion, that is 1.530 gram of CO2 and 0.625 gram of H2O. Find the percentage of carbon and hydrogen in organic compound. One question you have to do this. Okay, just do one question right now. Then I'll give one more question. Okay, you have only 2 minutes. Now let's start doing the question. Yes, done. Okay. So first, what is given? Mass of substance which is taken, that is 0.6723. Mass of CO2 is given, that is 1.530. Then mass of H2O is present, that is 0.625. Yes. Percentage of carbon, 12 upon 44 into 1.530 divided by 0.6723 into 100. Percentage of hydrogen is equals to 2 upon 18 into 0.625 divided by 0.6723 into 100. The percentage of carbon will be around 62.07% and the hydrogen will be 10.33%. So can you do this kind of questions? Yes or no? Can you do it?
Yes, sir.
Okay, I'm giving you one question for homework today. The question is 0.465 gram of an organic compound gave on combustion, that is 1.32 gram of CO2 and 0.315 gram of H2O. Calculate percentage of carbon and hydrogen in organic compound. In organic compound, you have to calculate the carbon and hydrogen percentage. So, can you do this? Yes or no?
Yes, sir.
Okay. Let's start with the estimation next. What is the time? Okay, we can do one more estimation. Okay, that is estimation of halogen. The method we will use, that is called Carius method. Okay. So what you will do, you will take a Carius tube. Okay. Carius tube is like this simple. This I'll tell you. We'll seal this end of Carius tube. Okay. What you will do, organic compound in this Carius tube with fuming HNO3. Okay. And few crystal of silver nitrate, AgNO3. Okay. And then you will seal this particular test tube, this tube that is called Carius tube. Now the Carius tube is kept under, or you can say kept inside the furnace. Kept inside the furnace. So you will see what exactly happened. Three things can be formed. Okay, either it can be a chlorine compound, either it can be a bromine compound, it can be a iodine compound. So the compound form will be AgX. It can be AgCl, it can be AgI, it can be AgBr. Okay, so we have three formulas. So if the Cl is formed, percentage of chlorine, okay, percentage of chlorine as the halogen in the organic compound, it will be atomic mass of Cl divided by 108 plus 108 is the mass of Ag plus atomic mass of Cl into the amount of substance formed, or you can say, okay, I'll change little bit. I'll change it. This will be very easy for you then. Percentage of chlorine. See, we know the mass of chlorine, that is 35.5. Okay, divided by 143.5 into mass of AgCl formed divided by mass of substance which is taken into 100. Okay, then percentage of bromine. 80 is the mass of bromine. 108 plus 80, that is 188 into mass of AgBr formed divided by mass of substance which was taken into 100. Then again, percentage of iodine. The mass of iodine is 127 divided by 235, 180 plus 127. And then mass of AgI formed divided by mass of substance taken into 100. Got it? Yes or no?
Yes,
Yes,
sir.
sir.
Let's do one numerical. Then we'll see you in the next class. Okay. A question is, in Carius method, 0.15 gram of an organic compound is heated and it gave 0.12 gram of AgBr. And the question is, calculate bromine percentage of bromine percentage. It will be 80 divided by 188. See, you will write everything. I'm not writing everything. You'll write the mass of the organic compound is this, the mass of the AgBr is this. Okay, so you'll write by your own. I'm not writing. And then into 0.12 gram of AgBr is formed, divided by 0.15, this was an organic compound, into 100, that will be around 34.04 percentage. So you can calculate like this. So I'm not writing the formula and all just because I have to complete this topic today, but you'll write everything. Okay, last the homework for you. 0.189 gram of organic compound in KDS method gave 0.287 gram of silver chloride of AgCl. Calculate Cl percentage. One more question. 0.301 gram of organic compound gave 0.282 gram of AgBr. Okay, and calculate percentage. Calculate percentage of Br. Okay, so three questions, two questions, these two questions, and one this question. I'll ask in the next class. Okay, I'll ask the answer. Definitely, I will ask the answer. And now the topic remaining in this particular chapter is percentage of nitrogen, percentage of sulfur, percentage of phosphorus, and one more thing. Wait, let me check. Yeah, this okay. Percentage of oxygen also. Percentage of oxygen. We'll see if it is necessary. Then we'll do this one. The rest will not do this one. Mostly 1, 2, 3. So these three things are left in this particular chapter. And whenever I'll in the next class, most probably on the Sunday, I'll take a class. Just because Thursday, Friday, Saturday will be Dipashri ma'am class for thermodynamics. So we'll complete this particular chapter on Sunday. Sunday definitely, because three methods are remaining. Three methods will complete this particular chapter. So just complete up your numericals. We'll see you in next class. If you have any doubt, you can ask right now.
Sir,
No doubt. Yes.
sir, once show the formula, sir.
Yeah.
Okay, sir. Thank you, sir.
Okay. No one is having doubts, so we'll see you in next class. Enjoy your day. Bye bye.
Thank you, sir. Yes, students, you can join the next session.